Okay, guys, so let's get started. So before we start the lectures, I'm gonna do this stuff. How do I admit the people here? You guys here? Any idea how to admit people?
How to unmute?
Admit all, I guess. That's it. Okay, so before we start the lecture today, assignment 2. I hope you started working on it.
But
Hold on, you still have a question? Already have a question? And so for assignment 2, basically, if I took that one from Radostas, so if you have Radostas, maybe you have the answer, but that doesn't mean it's a good thing to go and copy an answer. It's different. It's done differently. So in this problem, like the other one, you see there's 2 shear forces, each one on a direction. Okay. Here I clearly say something. Okay. Part A, you find the centroid cross section. Part B, do the calculation only considering the force on the y direction. No. Second part, do the same thing with this one on the x directions. Okay. I think it's a lot easier that if you combine both forces at the same time in the same equation. It can be done, but then it becomes complicated when you need to calculate the moments. Okay, that's why I request that you break it into 2 parts. Radosta did it all at once, okay? If you ask me, but do I need to accept more people or okay? So this problem is what? Statically determined, no? Okay, and this one is statically indeterminate, no? Okay, so again, I suggested to you, which I highly recommend, is that you do this with MATLAB. Okay, I mean, it's not that you submit to me the MATLAB, that you check your answers with MATLAB. We have done 2 or 3 problems in class to which you can rewrite the program and check your code. Okay, so you had a question over here about the assignment? You don't have the question anymore? Okay. Yes.
if we didn't do like part B and C, we just went to B.
If you did what, sorry?
If we like didn't do part B and part C, I just went to B.
Okay, but the question is, it can be done, but here I ask you to do this, there's a reason, okay? I mean, it can be done. I'm not saying it cannot be done. It can be done.
I did that.
Okay, but how do you know what you've done is correct or wrong?
I have the best support.
Okay, but did you follow our procedure or Radosta's procedure? Huh?
Yeah.
Which one do you follow?
Cheers.
Okay, so if you are confident about what you have done, it's fine with me. You see what I mean? The problem of using this equation directly is about the sign convention. Okay, so talking about that, that's a good question that you asked me over here. So remember over here, probably I posted somewhere here a document about the sign convention. Okay, if you're going to use the equation directly, remember here the SY is the VYs, no? So make sure you follow this sign convention because the equation was derived following this sign convention. Yes? Yeah, I mean, that's what I'm saying, okay, for everybody. But if you do it directly, this is the major problem, okay? That you might run off into it, is the sign conventions. Okay, so again, I mentioned to start early this assignment. So the assignment is due tomorrow. If you haven't started, you're gonna have a fun afternoon today or tomorrow. Yes.
Is it possible to get an IXY negative?
Yes. Yeah. Okay, so let's do one example. And okay, I don't remember this one, but I just printed. So again, I didn't want to move ahead with the material. I would probably move a little bit ahead tomorrow. But today I wanted to do something that can help you more as another practice problem to prepare for the exam. So let's see, it's just a little bit more complicated geometry over here. So let's see. There's one cross section. Let's see. This is what I've done here. Okay. Here we go. Now I think I have just one over here. So basically, you see the geometry of the cross sections will be more complicated. So this will be 1, 2. So we have here booms. This time we go back to the booms, okay? I don't do more problems about like the one we did the other day. Do you remember that one? You have one assignment. Guys, don't leave, please, please, please. I don't know how to. Don't leave the assignments until the last minute. It's going to be a disaster. Okay? The complicated part about this class is to do the assignments. They can be long. Okay? So please start early. I don't know this. And there's a force here, a shear force dy here of 10 kilonewtons. So this example probably is from Maxon instead of Radosta. So this would be, all these dimensions would be in millimeters. This is 240. Everything is symmetric. This one will be, oops, 1, 6, 7, 8. I forgot here, 8. That distance over here will be 60. 240. This distance over here is 240 as well. That distance over here would be 120. This will be 100. And this one will be 200. Okay, so let's see. We know that, let's see, B1. So this is symmetric equal to B8 equal to 200 millimeter squares. B2 equal to B7 equal to 250 millimeter square. B3 equal to B6 equal to 400 millimeter square. And B4 equal to B5 equal to 100 millimeter square. Okay, so basically, the geometry might be a bit more complicated, but the procedure should be the same, no? Like always. So first, let's see. By now, you should be able to recognize this. So first, this problem is what? Is it statically indeterminated or statically determinated? Determinated, no? Okay, so we can see over here, so it's statically determinated. So that's good. That way we can know what is the procedure, no? Okay. Before we start the procedure, maybe let's do here. Then let's start by another little, understanding of the problem. What about the cross section? The cross section is symmetric, no? So if it's symmetric, what does that mean? IXY equal to 0. Neutral axis straight to the middle, perfect. And then this also means that once we need to calculate the shear flow expression, this is going to reduce to the one we have been using all the time, minus Vy over Ixx, summation of B sub R, Y sub R. Okay, something also I haven't mentioned, but you can assume that you can write it here. Let's say skin not effective in resisting shear, because if it was effective, then we need to take that second term on the side, no? The integral side. Is that a question or?
Yeah. Question.
Okay.
So actually, I remember what it was from the homework. So this is when we have a Vy is a negative Vy over Ixx.
Yeah.
And since we have no Ixy, it almost goes out. So for the homework, since we have the Ixx, Iyy, and Ixy, would that bottom value be the Iyy times Ixx minus Ixy squared?
Correct.
Okay.
That's why they use math.
Okay.
Okay.
Yeah.
Instead of killing yourself. Okay. Yeah.
Yeah.
All right. So this is the question. So basically, now that we know this, we know. Let's do the small calculation up front. Okay. So we know Vy is 10,000. We need to find what would be Ixx, no? Before we start with the procedure. So we know here where Ixx, how do we calculate Ixx? We say was equal to what? The summation of the B sub R's. What do we need to do? B sub R squared, no? Okay. And as you mentioned, let me do a small figure over here. I think I'm going to do a bad figure, but doesn't matter. So now this one should be half of this one. Okay, it's not a good figure, but doesn't matter. I think you mentioned being very right is that if this is symmetric, the neutral axis is going to go straight through the middle, no? All right. So let's see. 1, 2, 3, 4, 5, 7, and 8. Okay, so basically, I'm going to go here down. So if we use that equation, let's do it slow, okay? Not planning doing too much today. So what should be this? We should have what? This is symmetric, so we can have what? Let's say B1 and B8, no? Okay, so let's do it symbolic if you want. Let's say this will be equal to what? B1, 1y squared plus B2, y2 squared plus B3, y3 squared plus B4, y4 squared plus B5, y5 squared plus B6, y6 squared plus B7, y7 squared plus B8, y squared. Maybe I can use that space over here. Okay, y1 will be equal to what? We look at this figure.
30.
30. So let's do immediately y8 will be equal to what? Negative 30, no? Okay. Y2 should be equal to what? $100? No? Yeah. Okay. Y7 minus 100. Y3. Oh, I could have done this one, the same thing, equal to Y2. Y6 equal to Y7. And we can do here the last two. Y4 will be equal to what? 50, and 1.5 negative 50, and we have all the other values. So basically, if we do the calculation, this is going to give you that IXX will be equal to 13.86 10 to the 6 millimeters to the fourth. Okay, so let's see. Now that we have this, what is step one? What do we need to do?
Make a cut.
We need to make a cut because we need to now have a starting point, no? Okay, so let's say we're gonna make the cut between 2 and 3. So let's say make a cut. Okay, so let's say we're gonna make the cut between 2 and 3. One, two, three, four, five, 6, 7. It should be alphabet. So let's put. Doesn't matter what you make it. Doesn't matter, but. Okay, so we make the cut here. What does that mean? Q to 3 is equal to 0. Okay, so now what do? We know Q23, we need to go around the cross section, no? All right. So we're gonna have here page 2. So let's say we start from Q23 equal to 0. Next, we can go to Q45. So Q45 will be equal to Q23 minus dy over IXX. Yeah, it's true. Why didn't go 3, 4? I have no idea. 3, 4.
It's a Monday.
So no, but it's good. Q23, but good. Thank you for letting me know. So what should we have over here? I was thinking about this part of the question. This should be B of what?
3.
Okay, B of 3.
1.
Y of 3, that we know that from before, no? So if you had your MATLAB code, you could just go and replace. Okay, I don't know if I did it for this problem last semester. Let's look at it. I'm not going to redo it, but if I have it, I don't mind showing it to you so that you can then look at it on the video and redo it, okay? So let's see if I have it or not. I'm sure I did it because last semester I changed my problem, so I think I redid a lot of MATLABs last semester. This semester I'm being a bit lazy and I'm reusing problems. So let's see if I have this one. I think that's one that I did with you, no? Did we do this one together? Yeah. Okay. So let me close this one, open script. No, new no. Open. Okay. As sure, when you sure. AE418. Spring 2023. I guess if this would be somewhere, would be here. MATLAB. Looks like it's this one. Yeah, probably this one. Okay, so let's see. Is that the one? Yeah, so it looks like it's this one here. So this is the data. Okay, as you see, I put the data here. Okay, I put here the distances of each one of the segments. Okay, that we know, and then I find by using the, Pythagorean theorem, you can find what is the extension for 1, 2, 3, 4, 5, 6, and 7, 8. No. Okay, I did the location over here as we just did over here. We calculate the area moment. I did it a bit different, as you can see. I can make the cut. So you see Q23, I calculate this. So let's see what happens if I run this, okay? I think this we could almost run by sections, no? So if we run this section, okay, I don't see the run section here. So let's run everything.
You can run the section by clicking the blue bar on the left.
This one here?
No, in the script itself, by the numbers, by the line numbers, the blue bar.
Oh, really? You see, I always learn something with you guys.
Yeah, you could know that.
Okay, so basically, what did we have for IXX? What did I tell you was 13.86? So probably we did this one in class together last semester, okay? So now if you want, we can use this. We can run now the next section that will be the Qs. Okay, that one we can just copy from here. So the blue bar, no, I don't have the blue bar anymore. Okay, awesome. Yeah, perfect. So, all right, so let me we have the values here. So let's see if that's the same ones that I have over here, minus 28.86, 32. Yeah, so I have them over here, but basically you can see the code. So if you want to create your own code, you can just come here and copy, okay? This is the step over here that we just did, make the cut. Let me close, so make the cut, we have this. And basically, you see that if this was an assignment, I just use the MATLAB code to check the calculations, no? But I still do through the papers or the presentation. So this gives you Q34 equals to negative 28.86. Q45 will be Q34 minus Vy over Ixx before Y of 4. This is equal to minus 32.4675. We still go around 56 equal to Q 45 minus Vy over Ixx V5 Y5 56 equal to, so that one should be equal to the 3/4, so minus 28.86. Q67 would be Q56 minus Vy over Ixx V6 Y6. This gives you, what should that one be? 0, no? By symmetry, no? You can go and check your calculations, very good. Then Q7
7/8 should be Q67 minus Vy over Ixx B7 Y7. That will be equal to 18.0375. Q81 will be equal to Q78 minus Vy over Ixx B8 Y sub 8. That will give you 22.3665. And finally, Q12 will be equal to Q81 minus Vy over Ixx B1 Y of 1 equal to 18.0375. Okay, I didn't put the units, but all these units should be newtons or kilonewtons? Newtons, okay. Okay, so if you remember, this is the step 1, we make a cut. What should be the step 2? What is step 2? Correct, so consider a constant shear flow. Do some, so now, because we did the cut, okay, we need to make this that it looks like the real case. So we have this again. So we have this, this will be half of it. This, what is the 1, 2, 3, 4, 6, 8. We're going to assume our constant shear flow. Okay. Okay, so we do this. Now it's just a matter of notation, it's tedious, but basically Q bar 1, 2 is equal to what? Q12 plus Q sub naught. So that would be equal to what? You can substitute over here, okay? I mean, I would just let the MATLAB do it, okay? I want to see that on the piece of paper, really what I want to see is the procedure. Q bar 23 will be equal to Q23 plus Q sub naught. Q bar 34 will be equal to Q34 plus Q sub naught. Q bar 45 will be equal to Q45 plus Q sub naught. Q bar 56 will be Q56 plus Q sub naught. Q bar 67 will be Q67 plus Q sub naught. Q bar 78 will be Q78 plus Q sub naught. And Q bar 81 will be Q81 plus Q sub naught. Okay, let me see what I've done here on the MATLAB. Okay, so let's see if I've done the same way. Yeah, so step 2, you see what I've done here is exactly the same thing, no? Okay, so let's follow a bit what I'm doing here, okay? Since I have it open. So it looks like next I'm doing this with the areas. Okay. Step 3. This is 0. Okay, so let's find out what I'm doing here. Okay, so what should be step 3? I mean, it's over here, but what should be step 3? We need the moment equivalence, equate the moment created by the external forces, needs to be counter-reacted by the internal forces, no? That's basically what we're saying, no? Okay, we could do summation of moments equal to 0, but I think it's better to think whatever is external needs to be counter-reacted by the external. So page 3. So step 3. We equate external moments to internal moments. So basically, we're going to say that summation of forces external, or okay, equal to the summation of forces internal, and here we need to select about which point. So let's see which one did I do here. Okay, so about, looks like I did it here about point A, and let me do a figure now. Okay, I will do a figure about which one it is. Okay, so again, we need a figure, but you see I'm kind of following what I've done over there. So let's do a nice figure now. Okay. Okay, here we go. Now I can do here 2, can do here 1. Okay, so look like this problem when I did it, I used the area. So let's do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think now remember a little bit this one. I think the difficult part is to find the areas in this one. Okay. So our point A over here, we took point A to be right on the neutral axis and be here at point A. This is our point A. And we know our force over here, Vy, is being applied over here. Okay, so if we do over here, summation of about point A external, what would be that moment? What is the moment created by Vy about point A? 0. 0. That's probably why we did it over there, no? Okay, now, summation about point A, about point A, no, 8, A of the internal. So again, there's multiple ways to do this. Okay, so let's start maybe by this end. Okay, let's go counterclockwise. Is that what I did over here? Yeah, that's basically what I'm doing. I'm taking the inspiration of, so you can compare really the MATLAB code to whatever we do in class. Okay, that's what I'm doing. Okay, I'm really trying to follow what I did over here. Okay, you see moments about external, internal. I start by Q81. Okay, so let's start by this one, Q bar 81, and then we can do it a little bit differently if you want. This would be equal to what? So Q bar 81. Okay, this is shear. So in order to get a force, what do we need to do? We need to multiply it by the distance, no? So S81, I'm going to use the same notation. So this will be force, correct? Yeah. Now times distance. What will be the distance between this force and point A? So it's whatever I call over there. So yeah, so will be whatever is. Okay, let's put it over here. This is I think on the figure I call this one D12, okay? Yeah. So what is D12? Let's see if I have it defined before. So D12 should be equal to what? Let's see, where did I define that? So D12, oh, D12 I have it here defined is given is 240, no? Okay.
Same as S23.
Yeah, and then S23 is also 400, but basically everything is defined over here, okay? You can see on the video. So I'm almost going to kind of follow seeing if that makes sense. Copy these equations so you can compare them by terms. So it would be Q81 S18 times D12 plus S, what did I use? 23 or 67? S23. Okay. If you have a question, stop me. Okay. In class is the time to do this together. So it looks like here on the MATLAB now, I'm talking about Q12. Okay. So Q12, the best way to do Q12 is to do 2. If you remember, no? Going through an arc, you have 2, A12, let's say, Q bar 12. This is for this segment, no? All right. So this should be everything. That's it. That's what I have there. Yes. Now we go to 2, 3. So this one should be pretty easy. So, oh, here another thing maybe we needed to plot, all right, is that I'm assuming all the Q's to be this way, no? So that all these ones I created a counterclockwise moment about point A, no? Okay, that'll be positive, then I let the math do. So then the next one will be what? Plus Q bar 23. This is the shear force. We need to multiply it by the length in order to get the force. So S23. And what would be the moment? What would be the arm? Sorry, what would be the arm? We need to have that distance over here, no? So what should be that distance? Yeah, but if we use the notation, I use S36 divided by 2, no? Would be half of that distance, no? Okay. I mean, I can use values. Do you want me to use values or do you want me to use symbolic? You want me to use values?
I would say, can we specify that as,
So let's say this would be,
right, it was Y3.
oh, you can put Y3 as well. Correct. So let me put the values if you want, and then I start. So this would be what? This is 400, no? I think you told me this is 400, no? Oh, 480. So this is 480. S81 is 60, no? And then from now on, I start using the values. Then A12 will have to do it. S23, 240. For what you told me. And S36, which is Y3. I don't have that distance. S36 we say was 200, so it should be 100. Be careful if you Y3 here it's going to work, but be careful because remember if you put Y6 then it becomes negative, no? So be careful of that. So let's use the values. Is that what you want? Okay, except for Q12, A12, we'll find out what that is. Now we go to Q34. So for Q34, what are we going to do? We're going to use the A again, no? I'm guessing is what I'm doing here.
Yeah.
2, 3, 3, 4. Where is 3, 4? Oh, I was looking at the, yeah. So you see, we're doing this term over here. So plus 2, A, 3, 4, Q bar 3, 4. So there's nothing we can do on this one. We need to find out what will be A12, A13, and A14. Okay. Now we go plus Q bar 4, 5. What is that distance? What is 4, 5? 4, 5, I think is 100. Yes. Okay. Look at the figure. Okay. You need to look at your figures, guys, because 4, 5 is 100. All right. And now what would be the arm? Point A is right here. So it should be what? 120 divided by 2, no? Yeah. I mean, you asked me to use the values instead of the dimension. So would be that one here divided by 2, no? Maybe we should put values over here. This is
What would be
100. This is 200. What else do we know? This is 120. So
why would it be divided by 2?
I don't know why divided by 2. Yeah, so it's good to check. So it should be 120. It looks like a 20, but it's a 120. All right, next will be Q56 will be 2, A, 56, Q bar, 56. Which I guess is what I did over there. Obviously, I'm getting confused about the lines. Yeah, 2A.
So you use 3, 4 instead of A56.
Because it's the same thing.
Same,
Yeah, will be the same area, no? But we can do that later, okay?
Divide 200 over 2 years and not the 120.
On which one?
Q23 divided 200 by 0.
Yes, because you need to find the distance between this, and we take a moment about which point. A. What is the arm? Okay, what is the moment created by the force going over here? Is force times arm. What is the arm? Is the distance between 2, 3 and point A, no? So what is that distance over here, from here to here? Is those 200 here divided by 2, no? Okay, so we have this. Now we go 5, 6 plus Q bar 67. We need to multiply this by what? I think this is 240, no? Is that correct? Yeah. So by 240. Now, so this is the value of the force. What would be the arm? This one will be again the 100, no? Times 100. Okay, for 7/8, we're going to do the same thing, plus 2 times A7/8 Q bar 7/8. Okay, so over here now I start to remember this problem. This is where you had the hardest problem over here to find the area. So, so this should be the equation, no? Okay. Now let me redo small figures. So, let's find out the areas. We need to find A12. So let's see what I put here, because A12 should be the same thing as, yeah. A12 will be the same thing as A7/8. And then we have A34, same as 5/6. Okay. Okay, so let's maybe start by, I don't know which one I did first, but I think 7/8 is going to be a lot easier than the other ones. Yeah, area 3/4, you see? So I did, okay. So first, let's say, okay, so I did a color here. So let's say A will be the total area. Okay, that, I mean, I'll let you do it, okay, but basically what should be the total area? There's multiple ways to do it, but probably the fastest way would be to do what? Would be to do like, you do this like a big rectangle, correct? And you remove these areas over here, no? Okay, there's other ways to do it. All right, now let's look first at areas. I think 3/4 and 5/6. So let's plot it. So let's say this is our point A. I might just do half of the figure. So this would be 3. Oops, maybe I should put 4, no? 1, 2, 3, 4, 8. 1. It doesn't matter what I'm doing here. Okay. So this will be 3. Here is 4. And here is 0.8. So that the area they should be A34, no? So let's see. How can you calculate that area? There's multiple forms, but if I just look at this one here, let's see. Looks like I've done here to here. This is 5. Okay, so A34. I'm just going to copy. Maybe we can do different. A34 equal A56. So let's see. What can you do over here? how would you calculate that area? Basically, what I've done is that what would be that total distance over here? All right. How do you calculate this area? Maybe you find a different way. Yes.
Just do, if you were to cut it in half and make a rectangle, so just do, 120 times the height of 100 divided by 10.
Okay, so we'd be, yeah, so we'd be, you did this, no?
So I did, yeah, so take the.
You
height
did 3, 4, no? You did that distance
Yeah.
times the height
divided by 10.
divided by 2. What is the distance between this point and this point? Is that the same thing, or let's look at it? Is from here to here is 50. Yeah, you could do it probably that way. All right, I'm just gonna copy the ways I did it here, okay? So A34, what did I do? Let's see what I did. I did S45 times D34. So basically I did the 100 because this is 100. Okay, I took that distance over here. Yeah. Okay, from here to here, from here to here. Minus D34. Okay, times 45 divided by 2. Did you see what I've done or no? We are looking for, I mean, you can do this, whatever. You can look at the code, whatever you want, just execute this one. It's just trigonometry, there's multiple ways to do it, okay? Why do I need to change folder? I think I just run this one. So we run that section. We run this one. And let's run this one here. Okay, so let's see. If we do this, we get A34 equal to 6,000. And that way, I think this is the same thing as you were saying. You had 120 times 100 divided by 2, no? So it should give you A34 equal to 60,000. Again, guys, you need to practice this stuff. Okay, so what he did, what he was saying to do is the height, so 34 times the height, no? Divided by 2. Okay, so we know this one will be equal to A56. Okay, so A56 similarly, we do the same thing, would be to 60, what, 6,000 or 60,000? 6,000, no? Let's see, that's what I think it is. Yeah, 6,000, sorry, 6,000. 6,000. Now, we do the area 1, 2 and area 7, 8. So area so A12 equal to A78. And I'm going to redo a small figure. So I'm going to have here point A. Yeah, sorry for that. So I do here point A. This will be our points. Let's see, 3, 6. I'll go here 2.2. Maybe I've done this a little bit too big here, but doesn't matter. Then we have here half and half. So that's from here to here. Yeah, 1, 2, 8. Seven and 6. Okay, and we need to do the area A12. So this one is go from here to here. and here to here. Basically, this is the area A12, okay? And again, you can do it on your own, whatever way you want to look at it, but I think the way I did it here, I don't remember what I've done, but I'll just show you. Oops. There's multiple ways to do this. I think last time when I did it, some people did it differently. And because I think I did this program in class live and the students were doing it on their own, we couldn't agree on the areas. So, okay, so let's see. This is the way I've done it. Okay, you can look at it and find what it is. Hold on 1 second. So we find A12 to be equal to, let's write here, 20,400. Let's say A12 equal to A78 equal to 20,400. Okay. And yes, you have questions? The what?
The area that we're measuring, you use 6 and 1 points instead of A.
Oh, yeah. I don't know why I've done that stuff. Yeah, so Thank you. A12 equal A78. So let me just redo the figure. I don't know what I was thinking about. So we have here 3 to 2. One, 8, 1, 2 here. 1, 2, 1, 2 here. Is that correct? Yeah, this one a bit too long. Okay. 7, 6. And here is point A. A21 would be this and this. Thank you. So this should be A12. And let's see if I remember properly. Thank you for this. If I remember from last semester, I think we couldn't agree on the areas, or somebody had a different equation. So I think what I did, let's see if I remember right. I think I did another model. So let's see, let's go and find out. I'm not sure. I mean, what could you do? If really you don't find it, you can go to CATIA, no? And find what would be the areas, no? Okay, but I think instead of CATIA, if I remember right, maybe I use CATIA, I don't remember. So, but I think I use another software to finish the discussion. But I don't remember what I did. Yeah, you see hexagon areas. So I guess it's this one here. I mean, they look two files of the same. But you can do that in CATIA as well. Okay, what happened here? Okay, so, all right, so I guess we might not be able to see it. Okay, that's very strange. Yeah, so I think here what I did is, I don't remember what I've done, but basically you see this would be the two areas, no? So I created the points and then I created two areas. And okay, no idea how to do this, but let's see, I'm sure there's a command to calculate the areas. So geometry, surface. Probably not, tools. measure surface area, I guess this one. So I guess I went here, I created this surface, no? I click over here, 6,000. Okay. What did I just do? Tools, measure surface. I came to this one after creating the geometry, 2,400. Okay. All right. I mean, this is the extreme. No, we couldn't agree. I remember now from last semester, somebody was doing differently, and I couldn't see what the student was doing wrong. So I ended up doing this. Okay. But you can do the same thing in CATIA, no? Yeah, if really you don't see how to do it. Okay. Okay, so basically this is what we have. So now step 4 will be, okay, so we substitute into the internal external equation. So let's see now. So what we do, let's see if I have the equation over here. Yeah. So before we do that, I can write here so that we have summation of about point A external equals summation about point A internal. Once you go and substitute all the values, you get 0 equal to minus 194 400 Q sub naught. I guess I got this from the MATLAB, so maybe we can execute that one. I guess I got it from here, from this equation here. It should be this equation here. So let's see what I get. Yeah, you see that one here, minus 194 400 Q sub naught minus whatever the value is over there, minus 796 1 2 3 4 5 10 to the 5 zeros divided by 77 equal to 0, and Q sub naught. Okay, didn't solve Q sub naught here. But let's go step by step. So this is what I have. Now we can solve for Q sub naught. Not sure why the MATLAB is not showing the value.
Try running the double function from a solve.
I don't know. I mean, let's see what it done here. Looks like it didn't solve here, no? I mean, let's try to. I mean, I run. It looks like it ran that semester. So, why it wants to change the folder? Why does it want to do that? Doesn't matter. So let's see. That would be everything. Okay, so you see, I don't know why. This is the equation we just defined, and this is the Q sub naught. Can somebody do that? Maybe I can just do it here, MATLAB. Yeah, I mean, instead of writing that, control copy. Oh, it's solved right there.
Down, yeah, answer.
Oh, yeah, here.
Yep.
Sorry. Minus 5.31. Minus 5.3177 should be enough. Okay. Newtons per millimeter. Okay, so that finally we did step 1, 2, 3. What should be step 4? I mean, we are done basically.
Wasn't it step 4 already? So.
Maybe. Yeah, to solve. Yes, probably. Yeah. I mean, what do you want to call it? But basically now, what is the only thing we need to do? We need to go back and substitute into these equations, no? Okay, everything we had. So if you want, let's be right over here. So Q bar 1, 2 will be equal to something, Q bar 2, 3, and I get all that stuff from the MATLAB. 3, 4, 5, 6, 7, 8, 8, 1. I will put the values. Then maybe I can do here some type of figure at the bottom. All right, so here we did 2. Oops, should be a straight line. I mean, guys, basically you see that if you decide not to do a MATLAB code, I mean, you're gonna have some very boring afternoons, okay? Or evenings. There's a lot of calculations, no? And they are repetitive and tedious. Okay, so please be smart and trust me, do the MATLAB codes, okay? First MATLAB codes, when you do programming, I don't know how to do this. Can I zoom out? No. Is you learn what would it be? Let's say you learn like 4 times, because first you listen, then you write it, then you need to program it, and then you need to run it and compare, no? So the good thing about when you do the programming yourself is that there's no way the program is going to run unless you understand what it's doing, no? Okay, so it's a good way to start. Okay, I mean, not a good way to start, but it's a good way to understand a program. You cannot program something that you don't understand. Okay, I mean, this is not really programming, but I mean, basically that's what I mean. Okay, so again, I think I have the values, but otherwise we can get them from the MATLAB. Let's go to the MATLAB. Yes.
In that little list that we wrote on step 4,
Yeah, I mean,
got Q45 and Q bar 6, 7 on the paper side.
oh, what did I do wrong?
We have 2, 3, 3, 4, 5, 6, 7, 8.
1, 2, 2, 3, 3,
5,
4. Oh, yeah.
6, 7.
Okay. So I need Q45, no? Okay.
And 6, 7.
Q45 and Q bar. Is that right? 6, 7. Okay, so again, now let's see, we get here the MATLAB. So, oops. Let's see if I can do it this way this time. So I don't know what I've done here. So QB12, let's go one by one. Looks like QB12 will be equal to what? 12.72. Okay. And looks like it's positive. If I scroll down, QB23. So QB23 is where we did the cut. So that should be equal to Q sub naught, no? So it should be equal to the minus 5.3177. I don't know why I took that many digits. Q34 equal to negative 13.177. I'm just going to put 18. Okay. Start simplifying.
You say 13 or 34?
34.1775. So 1.34.18. You should hear on the screen as well. Okay, I'm just copying kind of from here. Q45, I think that's the one I missed. So is minus 37. Whatever you want, 75 or 78, whatever you want. Minus 37 point, 75. Then 5, 6. 5.6 would be minus 34.18. Then we go to 6.7 is where also is the same as 2.3. So we had 0 is equal to, so 6.7 is the one here at the bottom, okay? Here at the bottom. So remember, here's where we made the cut, we have 0, 0, so it should be equal to the same as Q23. So minus 5.3177. Q78. $12.72, so the same as Q12. Q12, yeah. 12.72. And finally, 81, 17.05. Okay. Okay, so the last thing will be to do on the figure to put if they go positive or negative. So let's see, Q12 is positive. And do it that way. Q23 is negative, so Q23 should be going that way. Q34 is also negative, so it should be going that way. Q45 also negative, so it should be going from 5 to 4. Q56 is also negative. Q67 also negative. Q78 is positive. And Q81 is also positive. I mean, I don't know if you see enough, sorry for that, but right on figure. Yeah, just going back on the summary is that I figured that I did before that I actually redid. This one is not correct because point A needs to go through the neutral axis, so right across this one. So I redid this one to find A12, okay, for the class notes on the video. Okay, so remember here on the solution, what do we have? Let me here give the explanation. So we have this one, okay? Remember, all the problems, what we do is what? We have our structure. Yeah, I don't want to redo the figure again, but I mean, let's do it in general, okay? This problem would be similar if we simplify the geometry of having this. Okay? So in order to solve it, we break this problem in two parts, okay? First thing we do is that we make a cut, because once we make the cut, now we can calculate the Q's. Okay? Okay. Now, because we made the cut, in order to be able to come back to this one, to close it, what we need is to assume a constant.
The Q bar
Okay.
is.
So really Q bar is the final one. Okay, this is basically what we do on the procedure. Does that make sense? Okay, that's basically what we do. So the final answer is the Q bar, it's not the Q, not the Q normal, the normal Q. Yes,
Why take moments about point, like imaginary point A? but not-
you don't have to. Maybe.
So if we did point B, it would still be applicable.
0.3 will be the moment zeros. Yeah, you can do 0.3, 0.6, yes. The only thing actually, yeah, probably would have been easier. I don't know. I think that's what we did last semester. Okay. I think the reason why we took 0.8 because remember when we did the problem in class, the example like you have on the assignment, I think we did this one in class before, no? Yeah, it's because this one, if you really want to apply the 2AQ, okay, it's easier when it's half of the area of this one. I think it's easier to go to the middle if it's a circumference, but in this case, probably it is not easy. Okay. I mean, I'm not planning doing anything else today, so more questions. I mean, the assignment is due tomorrow. So start, I mean, obviously, if you haven't started, start today. Okay, again, so the people that did it with Radosta, I'm not saying one is better or easier or anything, but did you understand that basically we are doing the same thing, no? Yeah. What happened is that Radosta did at the end of the semester because he used the principle of virtual work that I don't think is necessary, no?
That's what threw me off.
Yeah, principle of virtual work. I know. But you don't need it. Basically, what you need is an additional equation. That additional equation, what is that? That additional equation we are using is that the angle of twist on the cell needs to be equal. Okay. And then to me, if you want people that to give with Radosta, I make a cut so that is 0. What he does is that he leaves this closed and he says there's going to be a redundant shear flow in the structure, which is actually our Q sub naught. I mean, I'm just saying the people that to give with Radosta, okay? But basically it's the same approach, no? Okay. So that's it. Again, work on the assignments, okay? Do your MATLAB files. Because what is coming next is we did this. This is constant cross-section, okay? Next thing we're going to be doing, because wings generally are what? Exactly, taper. So what are we going to have? We're going to have to be dealing now with shear flows into a taper box or wing box, no? Yeah. And then we first do the easy method, which is, I mean, they are both not that complicated, where the area of the stiffness is more or less constant. We can use the expression of the Q's that we have been doing. But if there's also a big change on the area of the stiffness, we need to use a different approach. Okay. So that is what is coming next. So this even more calculations, more MATLAB imply, no? Okay. All right, guys. See you tomorrow. Yes. Last question. The thing that I do, I don't post the MATLAB codes, not because I don't want, it's because if you want it, you can go to the video and you can copy it. That thing is the best way for you to learn it. Okay. So I don't mind if you want, I don't mind if everything is not showing, send me a text, and what I do, I create another video where I make sure you can see the whole video. Yeah.